Hi everybody, I'm Jared Michelle once again, and this is my presentation for FSU's COP 4020 programming languages and the programming language D. Here's a quick overview of what I'm going to go over. Start with the history, move into what is D, why did they create it, why should anybody use it. It's based off of C++, so then we're going to talk about what was removed from C++ to make it, and what was added to C++ to make D, and then we're going to go over some conclusions and final thoughts. D was created by a man named Walter Bright of Digital Mars, and it was first created and released in 2001. Walter Bright was very versed in C++, and he was first known for creating the first C++ compiler that compiled directly into object and then linked into executables, as opposed to the previous compilers which first compiled into C and then down to object and etc. Walter Bright received his BS in mechanical engineering from Caltech in 1979. In 2006, Andrei Alexandrescu was added to the team. He's Romanian and is primarily a C++ programmer. Little history of his schooling: he received his master's in electronics from the Polytechnic University of Bucharest in July of 1994. After that, he came to America and then received another master's and then a PhD in computer science from the University of Washington. So it was first released in 2001, but the actual first real stable release, version 1.0, did not occur until January 2005. Currently, it is available in the version 1 and version 2 flavors on digitalmars.com, and they do suggest that for new projects or for the first time using the language, you do use version 2, as version 1 is currently in a maintenance mode and there's not a whole lot of support for it right now. So if you want to play around with this language, grab version 2. And the changelog shows that the most recent version is 2.060, which was released August 2nd, 2012. D is based off of C++, and that's kind of the whole point of it. It adds quite a few features from Python, Java, and C# and some other languages, but the main point is that it is a C++ derivation. It's statically typed and then compiled into object files and linked into executables just like C++, so you'll experience it just the same way if you know C++. It's not a scripting language. It doesn't require a virtual machine. You just compile it into the executable or link it into the executable and then run it as long as it's compiled on the proper hardware. So why was D created? The point was to take C++ and take the features that Walter Bright liked about C++, like the high functionality and the ability for very low-level performance enhancements, and strip away all the confusing, sluggish parts of it, things that he didn't like, and add a few features from some of the newer languages. An interview with Walter Bright revealed why he created it. He states, "Over the years, C++ has grown by layering on needed features without disturbing backwards compatibility. Often this results in some very strange rules and surprising corner cases. C++ has reached a certain level of maturity now. Its period of rapid evolution is over. So the time is right to see what can be done with the redesign." So why use D? Well, as I stated before, D is based off of C++. So if you want a language that's very much like C++, with a few extra maybe Java or Python features, and a few of the difficult parts stripped out, like memory management, pointer debugging, and others, then D is probably the language for you. It's object-oriented, garbage collected, which we'll talk about later, and it is a systems programming language. If you're familiar with C++, then D will be very close, as it has the same general feel and syntax. So because D is based off of C++, the core of the language and all the syntax is very similar. It's all started from the same place. Bright and Alexandrescu wanted to do this to reduce the learning curve, so that any C++ programmers that wanted to transfer over to D would not have a very difficult time. They would just have to learn a few extra nuances, a few other syntax points, and then it'd be very easy. So on the next slide, we're going to look at the simple Hello World program between C++ and D to see how similar they look. So on your left, you have the C++ version, which you have the pound include of the library to do the input-output, simple main program, and then the output to the console with Hello World. While on the right, you'll notice immediately a big difference is they use import statements in D as opposed to pound includes, which I will talk about later. There's two versions. One is the simpler version on the bottom, the top version is a little more in depth as it has a main returning an integer, and it has the character array for the arguments. It uses the printf statement, which is very familiar to many C and C++ users. And the bottom one uses a D write line, and obviously there's no return as main is voided. So the things I'm going to talk about what was left out of C++, what was stripped from to create D, are these following things. The C source code compatibility is left out, C preprocessor and macros, multiple inheritance, namespaces, forward declarations, pound include files, and 16-bit support were all left out, so we'll talk about all of them. So first of all, C source code compatibility. One of the big complaints he had was that C++ was trying to expand while all at the same time maintaining backwards compatibility. He found this not to be very realistic, because as you're trying to expand into the future and create better code and a better language, you can't carry along all this baggage that C++ does with C. So he completely got rid of any backwards compatibility. dlang.org states, realistically, nobody is going to convert million-line C or C++ programs into D. Since D does not compile unmodified C or C++ source code, D is not for legacy apps. So this is for fresh projects or a new language, not to take C and C++ code and convert it, as that would not be very efficient with D. He also decided to get rid of preprocessor commands and macros from C and C++. He thought that macros were almost growing into their own language, in the way that at the beginning of the program you'd have this whole list of macros and preprocessor commands written in their own language, and then you took the C++ program. And Bright basically said, well, why not put all the functionality of those macros and preprocessor commands and put them into the core of the actual language? And that's exactly what he did. He stripped them, put them in the language, and maintained the same functionality, but from within D. He also got rid of multiple inheritance, which is kind of an interesting topic because multiple inheritance isn't even necessarily known to a lot of C++ programmers. It's not necessarily obscure, but it's not used very often. The point of it is to make a child class that is derived from multiple parent or base classes, so it can draw functions from all these different base classes and attributes. And it can be very powerful, but at the same time it can get very convoluted and difficult if you don't know how to do it properly. So Bright got rid of this completely. He decided he could maintain the same functionality of multiple inheritance, or at least close to it, by using single inheritance and combining that with a template. And that's exactly what his goal was, to maintain the same functionality of multiple inheritance, but make it much easier to use from the programmer's standpoint. Namespaces are essentially where you store different pieces of code and you can draw from them. So if you have namespace A and you're writing the program using namespace B, if you want to use some class from namespace A, so you have to reference namespace A and say that you're taking this from namespace A. He does a similar thing with modules in D, but he finds modules to be much easier to manage, and we'll talk about those later on, what was added to D. For declarations, this is really interesting. He did a lot of work with declarations and definitions of functions in general. So for declaration is the fact that you must declare a function before it's referenced in any other function. In C++, that was in C. In C++, he kind of advances it with members of a class referencing other members of the same class before they're declared or defined. And he just advances it completely with D, saying that for declaration is not necessary at all. A function can be referenced in a previous function without ever having been declared or defined. And I'll talk about that later because there's a few other interesting features with this that he added that helped language a lot. Include files were a big point of contention for Walter Bright. He did not like them, he thought they were clumsy, and he thought they were inefficient. Because what include files do is they actually transfer over entire chunks of code, of C or C++ code. So when you run the compile on something that you've included a ton of different libraries in, it has to recompile and reparse that code over and over again every time. So what he chose to do is use imports, and he imported the symbol table so that when the compiler went over it, it was already parsed. You didn't need to do it over again. It was more efficient. You can add many more libraries without increasing the compile time by any significant amount. So he went from the include, the pound includes, to the imports to make the compiler more efficient. Now, the whole purpose of D really in my mind, as how I see it, is that he wanted C++ but without all the baggage. And this is where the 16-bit support was lost, because he said nobody uses 16-bit computers anymore, they're not necessary, we're just not going to allow it. So they don't have any support for 16-bit computing, and his purpose was that he wanted to move into the future. It's no longer necessary, so he offers support for 32 and 64-bit systems with D, but not 16. So you kind of look at this and say, you know, this really still just looks like C++. There's a few changes, you know, they stripped a few things, a little less powerful now because of the things they stripped out, but it still looks like C++. Well, this is where all his additions came in. He added features from Python, Java, C#, and he felt these features would make C++ more usable for a programmer, a little less flexible than C++, but overall a better product. So I'm going to go over those additions. So the added features of D that make it different from C++ include, among a few others, these are the main ones, modules, function declaration versus definition, which is quite interesting, we'll talk about, array features, and the contention creating garbage collection, which we'll also talk about. So modules, as we discussed, are kind of a different way of handling namespaces. Instead of storing code in these namespaces and then including them over perhaps, or referencing them and putting them in the same file system, he created modules, which is entire sets of source code. So you have the entire module and import it into your new program, and it has all the same code. It's very similar to namespaces. It's just Walter Bright felt it was more efficient and easier to deal with. So modules are just kind of another thing to get used to, but they still, in effect, are the same idea as namespaces, where you can store other pieces of code and then import them over into your new program if necessary. So the function declarations, definitions are changed a bit in D, and it is a very elegant solution to just some useless bulk in C++. Instead of having to declare your functions and then define them later on as you do in C++, D allows you to just define the function. You define it, the compiler is then able to essentially extract a declaration from it and then use that for the declaration. This also allows you to get rid of that forward declaration, because now you just define a function, it can reference a further function that hasn't been defined yet, and then the compiler does the job of pulling the declaration out and then applying that later. The arrays are changed up a bit in D in that they're simplified. In C++, you had static arrays in the language and then dynamic arrays, which you had to pull in from STL libraries. Well, D puts both of these static and dynamic arrays into the core language. So you see here how you can declare a static array and a dynamic array, and the only difference is whether you put the size into the declaration. It's very simple. The dynamic array then holds the size of the array itself and other information about the array that you can reference when using it later. C++ does it through the libraries. Walter Bright decided to put it right into D, into its core, and that makes it way simpler to use. Garbage collection is interesting because some people may like it and some people not. In general, garbage collection is just a term for automatic memory management. So in C++, you allocate memory, and then you have to later deallocate it in order to prevent memory leaks or overflows. Well, what D does is it has a function or a feature drawn from Java, which is the garbage collection. So if you allocate dynamic memory anywhere, a garbage collector will come along at its own convenience and clean up all that memory to prevent these memory leaks and overflows. The reason some people may not like it is because some C++ programmers that like to do this themselves with destructors can create very efficient code that deallocates memory exactly when they need it. But for the average programmer, this is a pretty cool feature because you don't have to worry about dealing with all the memory management yourself. So overall, many C++ programmers think if you want to use a programming language like C++, why not just use C++? And that's kind of the basis for their argument. It is a little more usable, D is. It's a little less finicky, but there's also less flexibility than C++ has. So, you can play around with it, see if you like it, but in my opinion, it's almost like a Frankenstein language. There's different pieces and parts that are added and removed on this one base of C++. So that's my presentation. I hope you like it. Thank you.